Hey, good afternoon. Um, Today, I know this is a bit late. We were supposed to submit this Thursday, but I was a little busy. Um, we're going to go over some construction modeling, and we're going to be continuing the construction modeling we did last class. And we'll be doing construction modeling up until next class tomorrow on Monday, and then on Thursday, on Wednesday, we will switch to modeling techniques to create 4D schedule simulations, modeling building elements to reflect structure techniques, adding information to building model elements for future data extraction and analysis. So then on Thursday, we're really going to get into how to use the data in the model that we make to do construction management tasks. Um, but for now, we're going to go. So what we're going to do today is, if you see here, we put some ductwork into the model, and of course we cut out this little part in the wall. And again, we manipulated some parts and we changed from original. So this was originally, wood flooring, and then this is concrete, and we justified that with, say for example, somebody was to walk into this building with wet shoes and they were to walk on the concrete pad rather than the hardwood as to not warp it. Again, this could be used for tile or whatever purpose needed. So we're going to go ahead and expand upon what we did last class with making the parts and editing the parts. And we're going to finish up modeling this building with parts. And we're going to add some mechanical modeling, especially to close off this duct. Put a little diffuser there and some mechanical components in here. We'll also put some diffuser in each one of the rooms. And we'll make the ductwork go into the floor above it. So we'll edit the model for that, and we'll maybe get into plumbing work. We might do that next class, though, depending on how far we get. This one will be a little shorter. This should last about 30 minutes or so. So it'll be kind of like a crash course for mechanical modeling for the most part. So what we're going to do to begin, let's look at this ceiling plan. Can we see our ductwork? We cannot. So let's find out where we can see our ductwork. In order to see our ductwork, we may want to go here into the ceiling plan and duplicate it. And so we'll duplicate that by right-clicking on level 1 and hitting duplicate, and then we'll make this level 1 copy 1, and we'll just rename this to level 1 HVAC, and you might call that HVAC. I've called it HVAC for a long time, and so I'm just going to continue calling it HVAC. So here we have level 1 HVAC, and the reason we don't see it is that our cut plane is too low to see the ductwork. So you see the top of this is 10 foot high, and the cut plane is at 7'6", which means that if the ductwork is, I believe, at 9 foot, the cut plane is, a foot and a half below that. So in order to see our ductwork, we need to go ahead and make this go up to 9 foot. Let's see, I believe that's where it is. I'm not 100% sure. Yeah, here we go. As you can see, the ductwork appeared, and we have our oval duct right here, and it has a nice elbow joint in it. In addition, it has some more ductwork this way. And as you see, there are two little plus buttons, and that's to go ahead and add a T-joint into the ductwork. But we don't have a T-joint defined, so what we're going to do is define that T-joint. So in order to do that, we have to select the ductwork and go to Edit Type, and we need to go to Routing Preferences. And as you see here, we only have an elbow defined, and we obviously don't want just an elbow defined. We want the T and the junction and the cross. We want all this defined so that we can model our ductwork freely. So in order to do that, at the junction, we don't have any loaded. I have those loaded, and we don't have any T's loaded. So what we're going to do is say OK again, and we will go into, we'll hit escape, and we'll escape from this, and we'll go into systems, and we will go to the duct fitting, and we will load load families. And so we go to duct, fittings. So it's an accessories just for vehicles. Okay, so these are the dampers and the filters. This is part of your ductwork system. So when you're actually putting the system together, you're going to have your dampers and your filters. And your system, of course, your dampers to restrict the flow, and your filters to make sure you have clean air in your building. So let's go to fittings, oval. Let's go to T's. And we'll go ahead and load all of these as we did before. And we'll select open. And so that loads all of our T's. And then we will go back in, we'll go to duct, fittings, oval. And I don't believe we have any crosses, so we'll go ahead and make some crosses. We'll load all these. And again, what we're doing this is for is so that when we go ahead and model this, it will be able to, in the case of a cross, it goes straight over here. Whoops. It goes straight across, and then it goes straight up, and so it's like a T. A T is like a capital T, and a cross is like a lowercase t. Go back into duct fitting, load family, duct, fittings, oval. We'll load some caps in here. We'll load the oval end cap in here. Oval, offsets. We'll load that oval offset, and what that is, as you can see in the little preview here, it just kind of offsets the ductwork in case you need to move over a little bit. Go to duct, fittings, oval, transitions. Of course, this transitions the size of the ductwork, because as you go along your ductwork, it has different size pipes, different size ducts. We're going to use unions. Load the union. And we'll go to the Y and load the Y. Now that all this is loaded, and the reason we do that is, as I said before, you can change, not necessarily change, but you can route your ductwork as you would like it. And once you've finished routing your ductwork, you can purge your unused, and we will do that at the end of the project, and I'll show you how to do that. Let me make sure I did accidentally place this cross here. Let me get rid of that. And we can go back to level 1 HVAC. And we'll go ahead and click on our ductwork. And we'll hit edit type. And we'll go to routing preferences. And we'll go to our junction. And let's go ahead and go oval T conical standard. At our cross, let's go oval cross conical standard. And we're going to go ahead and do this with just about all of them. Standard. We don't have a transition in here, any of them loaded. Our union, we do have the oval standard loaded. We have our oval end cap loaded. And so this should allow us to do just about all of our modeling. If we were to go from an oval duct to a square duct or a rectangular duct, or a round duct, even though our duct is relatively round, we would have to use a transition to do that. We're not going to do that though right now. We'll just hit OK and then hit OK again. And we can go back here and we hit this little plus button, and that converts it to a T, as you notice. And if we go into the 3D view by hitting the little house up in the top, you can see it obviously transitioned to a T. Let's go back into level 1 HVAC, and let's go to duct, and automatically connects. We can go here, right to the endpoint. Let's go about midway through this room, and we'll make it the same distance as the other duct. Now we'll go ahead and place a duct here in this room, and let's say we have a line at the front here. Let's say this line goes ahead and goes in the middle. And let's go ahead and put some ductwork in the bathroom. And we don't have any in the reception room. So what we're going to do, we're going to go here, hit this plus button again, make that into a T, and we'll connect it right here. put it right just like that. Just in a series of clicks, and the T's automatically get loaded into wherever we're drawing. So if we go ahead and look at this in a 3D view, this is about what our duct system is going to look like. Now this is not completely realistic because it's all the same size, and obviously your trunk line, which is your main line right here, will be larger than your branches. But we're not going to get into modeling the size of the branches. However, I can tell you that Revit has a feature as part of the program that it will automatically size your pipes. So all you have to do is you have to select the splits in the system, and it will size the pipes according to what kind of flow rate you want coming out of your diffusers. However, we're not going to get into that right now, or probably not in this class. If we have time next class, we'll get into that, but for right now, we're not going to do that. In the meantime, however, let's go ahead and model this building as it would be if it were to have this ductwork in it. So just like we have this cut right here, let's go ahead and make this cut everywhere because it won't take us too terribly long. So we can go here and do divide parts, and let's go ahead and edit our sketch. Set the reference plane to pick a plane, and we'll pick this front plane, and we'll hit this little rectangle. We'll go from right here to right here, and we'll hit the check mark, and we'll hit the check mark again. Oops, I don't want to select that part. Let me see if I can go for this. Might have to do this individually, so we go exclude parts. Just like this, exclude parts. And we have a nice problem going on here. So let's go ahead and make our rectangle up everywhere. Let's go ahead and get rid of that division, because I know that we went ahead and made this one very easily by going through this side instead of that side. So let's set the plane over here, hit OK, hit this, and go ahead and make another rectangle. Make it about that size, hit the check, put another check, and we'll go ahead here and select this. We'll go to exclude parts. And why are we not going away here? Sometimes you'll encounter problems like this with Revit. It just doesn't really go along with you. Let's go here to divide parts again. Edit sketch, rectangular. We gotta set our work plane to pick a plane. Front here. Go to rectangle again. And go below it. Just to larger than the size of the pipe. Hit check mark again. We'll highlight this part, exclude parts. Anyways, we continue this process along each one of the elements here that intersect with the walls. So, moving forward, let's go ahead and place some mechanical equipment into the project. And actually, let's place our diffusers in here first. So let's go back to this ceiling plane for level 1 HVAC. Go to systems, and we'll go to air terminal. And we need to load an air terminal, but instead of going this route, because this also often produces errors, we're going to fix out of that. We're going to insert, go to load family. We will go to mechanical, AVP, air air side components. Go to air terminals. And we just want a supply diffuser, a hosted supply diffuser. Let's see here. We want a circular neck, because what will happen when we go to place this, it'll want to connect to the same kind of ductwork. So if we put a rectangular neck on there, it won't connect. So let's go ahead and go to round neck, mounted, and we might still have a problem because it won't necessarily connect due to the fact that this is an oval pipe, an oval duct, and it is a round neck. So let's go ahead and go back to duct fitting, go to ductwork, we'll go to fittings, go to multi-shape, go to transitions, and as we see here, here are all of the transitions. We'll go ahead and load these into the project. And we will go back to our duct here, go edit the type, go to edit. We'll change these transitions. We'll go OK, OK again. And in fact, we may want to go ahead and use a different terminal. We will use a square terminal just so I can highlight, just so we can show how to use the difference in fittings. So let's go ahead and go down here to mechanical, MEP, air side connections, air terminals, and we'll go to supply diffuser, go to circular, rectangular neck, and so the diffuser will be circle, however the neck will be rectangular. So we're kind of going circle, rectangle, circle, but it'll highlight a point. So go to your systems, air terminal, and it's already highlighted. And you see here the elevation is 4 foot 0 inches. Let's go to 8 foot. So that'll put it in line with our ceiling. And we can go ahead and go into the 3D view to place this. And it looks like it's upside down. And it is. So to fix this, we will go into the component, we will select rotate, and we will go to a front view. And it looks like this is completely locked here. I'm not really sure who decided to have an upside down diffuser. Whose genius idea that was. Anyways, as we can see, we can place our ductwork, and I'll go ahead. We can place our ductwork in here as noted, and we'll go over placing the terminals in class tomorrow. So we'll go back to level 1 floor plan, and we will go to our mechanical equipment, and we will go to our rooftop unit. Of course, we need to put this on our rooftop. So let's go ahead and finish up our roof. We'll go through, and we'll go to our 3D view. We'll go to our hidden elements. We'll go ahead and select these elements, or right click, and unhide and view elements. And this will show our hidden elements. So we will deselect that. And I don't believe our floors have been placed in here, but that's okay because we can see our ductwork, and that's what our goal is right now. In the meantime, we're going to place our roof. And so this is going to be a flat roof. It's going to go roof by footprint. We're going to go to level 3, which is the top of level 2. So you can see here, level 2 looking downwards, and I believe this is the same as the level 2 ceiling roughly. We're going to go ahead and go to level 3, and we'll select roof by footprint. And we're not going to have any defining slope because this is going to be a flat roof. We have the steel truss, insulation on metal deck, EPDM, and let's look at the composition of this. So as you can see here, it is a nice membrane, a rubber membrane that's on top of the roof, and this is used commonly for flat roofs, which is what we're building here. So let's go ahead and select each one of these walls on the exterior of the wall, and we'll hit this check mark, and we'll hit yes. We want the walls to extend to the roof. And we can see the roof right here sitting on top of the building. Now, this is not necessarily the prettiest roof of roofs, but for an office complex, it works. And as you can see here, you might be wondering why is this open? It's because we have our show parts option on. So if we change this show parts to show original, it will go back to being closed up. But it is shown due to the fact that we have our annotation like this, and so this will be shown unless we go ahead and make a different 3D view. But for right now, we're going to keep this open just to highlight some differences in the different views. And we're going to go ahead and we're going to place our mechanical equipment on the roof. So we have our nice rooftop units. Let's go ahead and put a 5-ton unit here. Let's place this on the roof, but it's not level 1, it's level 3. And before we place it, we need to know the offset distance. So this roof is exactly 1 foot 9.5 inches thick. So let's go ahead, go to mechanical equipment, offset 1 foot 9.5 inches. We'll apply, and we'll go here and let's look at our floor plan. Our stairs are over there, right? You see through this window, so the mechanical room looking downward is right about here. So let's go ahead and place it right above the mechanical room. As we can see here, it's right. It's in line with the mechanical room, and it's sitting on top of the roof, which is very typical for a lot of commercial buildings to go ahead and put their mechanical equipment on the roof. So as you can see here, there are connections for each of the systems. There's a water line going out, there is air going in, there's air going out, and there is electricity right here. There's an electrical hookup, and we may or may not get into how to hook up all the electrical and the plumbing to this, but for now we're just going to go ahead and try to connect the ductwork. So in order to do this, we are going to actually hide this roof, so you can see it's a clear line straight down to the other ductwork. And look at it from the top. It's sitting just about right on top of the ductwork, so let's go ahead and move this back a little bit to right here. I'll show you why we're doing this in a little bit. And let's go ahead and make this connection. We'll go out to, let's say, whoops. We're going to want to make this ductwork the same as our ductwork down here, so that we don't have to make another transition. So we have a 12 by 12 right here. So let's go ahead and click on this mechanical unit, and we'll hit the plus button, and let's change this to 12 inches, 12 inches, so we'll make it go out just straight right here. As you can see, it has a little transition from its obviously rectangular out part to the more circular ductwork that we have. And we want to connect it to this ductwork, but it won't let us automatically connect. So this is obviously a problem. So let's go ahead and here and hit inherit elevation, inherit size, and automatic connect. And we'll go here from this pipe and we'll see if we can. There's no auto route solution found. So that's pretty typical. What we have to do there is we have to go to this duct fitting, and we'll go down to, let's see what fitting we have preset for our duct work. We can go here, we'll go to edit type, edit, and we have an oval T conical standard. We need an oval elbow board standard. So go here to systems. Let's go here and we'll go to oval elbow board standard as we have in the rest of the system. And let's go ahead and connect this. Unfortunately, this has a cap on it, I believe. It does not. So let's go ahead and do the duct fitting. Oh. Should be on level 1. This should be 9 foot tall. And of course, we're having a few issues, but it connects right here. We need to rotate this. So let's go ahead. Let's hide the rest of our building with the exception of the mechanical equipment. So let's go here, mechanical equipment, ducts, duct fittings. And select OK. We'll hide and view elements. And we'll rotate this. Until it faces upwards. As you can see. Now let's go ahead and put one more on to make a 90-degree turn. And as you can see, there is a 90-degree turn right here. Now in order to connect these, let's go ahead and place the same kind of elbow on this equipment. So we will place it right at the end point, hopefully. And we will rotate it until it faces downwards. And we will place another fitting one at the end of this to align it straight down with the other duct. So let's go ahead and grab a duct here. 12 by 12, automatically connects, automatically inherits elevation, automatically inherits the size. And we will connect the ductwork. By clicking the bottom. And let's see here. Looks like these are not completely lined up. Nope. So let's go ahead and align this in a modify tab. And we can just hit AL. And we can align this to this, I believe. Let's go ahead and select this. Shift. And click these. Actually, let's go ahead and do this. And we will move this over to the right to fit with the other ductwork. can see a line is directly over top of the other. So we'll go to Systems, Ductwork. So automatically connect these, and see if I erase of anything, this thing will finally connect. Anyways, as we're about 30 minutes in, I've got to finish up some work today, so I will leave it at this. I will post this video on the site. You can go ahead and add to your ductwork like this, and we'll go over this in class, and we'll finish up the construction modeling tomorrow. Thank you very much, and have a good day. Go ahead.